Hey folks, in this video we're going to use the ideal gas law to do some calculations. We have a situation where we have a bicycle pump pressurizing a tire at 565 milliliters of volume and 647 kilopascals. First question is, how many moles of air will we have under those conditions? And then we're going to ask what the volume would be at 101 kilopascal, which of course is roughly 1 atmosphere of pressure. So this 101 kilopascals is actually essentially the atmospheric pressure that we normally experience. So how do we compute then the number of moles? We use the ideal gas law, rearrange it to calculate moles. Here's our equation: pressure times volume over R, the gas constant, times T. Now, depending on the constant that we're using for R, we have to be careful about units. I'm going to be using the constant 0.8206 liter atmospheres per Kelvin mole. If I'm using that constant with these units, it means my pressure should be in atmospheres and my volume should be in liters. So we have volume in milliliters and pressure in kilopascals. So let's go ahead and convert kilopascals to atmospheres. So we use our conversion factor, 101.325 kilopascals per atmosphere, and we calculate the number of atmospheres to be 6.385. The volume, of course, this one's easy. 565 milliliters is 0.565 liters. The other thing, of course, is that we need to make sure temperature is in kelvins. So we use our conversion here by adding 273.15 kelvins to the 21.7 degrees Celsius. So plug and chug. Plug and chug in this case, plugging these numbers in, we're going to calculate the number of moles as 0.149. Easy peasy. All right, now, the second part of our question was, what volume did the pump transfer at 1 atmosphere, 101 kilopascals? So we do the same thing and we do our conversion. I already mentioned the fact that 101 kilopascals is roughly 1 atmosphere, but we can use our conversion factor and we have 1 atmosphere. Now, in this case, we could do this two ways. We could go ahead and use the number of moles that we calculated in the first part and use the ideal gas law, V equals nRT over P. But if we note that the temperature at 21.7 degrees is the same in both cases, then we can use Boyle's law here and note that P1V1 is equal to P2V2. Let me go ahead and write that in. Knowing that P1V1 is equal to P2V2 makes life easy. We'll just take our pressure of 6.385 atmospheres and our volume of 0.565 liters, which is what we used in the first part, divided by P2, the pressure of 1 atmosphere, and we're going to get our volume of 3.62 liters. So that's all there is to it. If we're doing it that way, because the temperature is constant, we can use Boyle's law. Now, you should be careful, because if the temperature in the second part is not the same, then we would have to use the ideal gas law, the full ideal gas law, in order to do that calculation. So that's it. We note that at 1 atmosphere pressure, the volume of the air that would be pumped into the tire is 3.62 liters. Under the pressure within the tire with a volume of 565 milliliters, we have a pressure of roughly 6.35 atmospheres. So I hope that's clear. Let me know if you have any questions.